Okay, chemistry, now that you know a little bit about pressure and you learned about something about gases last chapter, we're going to just be getting into a bunch of laws. And yes, you will need to know the name of what law goes with which law. And they're all about gases because this chapter is about gases. So this first one we're going to get into is something called Dalton's law. We talked a little bit about it in the last lecture. It states that when you have a mixture of gases in an enclosed container, that the pressure that those gases exert on the container is the result of the total number of collisions of each gas per unit of area of the container in a given time. It also states that when you have a mixture of gases, each gas has an equal chance of colliding with the container walls, which leads us to this idea of partial pressure. What is partial pressure? Partial pressure is the pressure of each individual gas in a mixture of gases. And Dalton's law of partial pressure states that the total pressure of a gas mixture is the sum of all the partial pressures of each gas in the mixture. So this is the equation for that right there. Quickly, I had a problem in here about vapor pressure of water, but it's not on the test, so I'm not going to show you the problem. I don't want to take time up for that, but I will explain this a little bit to you. Often when we collect gases in lab, they are collected over water. So basically you have water in a tube here, and then you do some kind of a chemical reaction. For instance, when you add your hydrochloric acid to your magnesium, that creates hydrogen gas. And so what happens is, since the gas is buoyant in water, the gas will bubble up into this tube and push the water out. All right? So the gas is bubbled into the tube, and when the level of the liquid inside reaches the same pressures inside and outside of the tube, here's our gas, our sample of gas. Now, so that gas has been collected over water. All right, therefore, because it's collected over water, it is always mixed with water vapor. And therefore, you have to count the water vapor as part of one of your mixture of gases when you collect a gas in lab. That's the whole point of this. And therefore, we use this little thing. And therefore, anyway, like I said, this isn't going to be on the test, but we'll throw it at you because it's in the notes, and I don't want your notes to confuse you too bad. Evaporated water molecules will exert pressure just like the gas molecules, and that is called vapor pressure. So when you're collecting gases in a lab over, you will have to know this for the test. It's a different problem I'm not going to do with you, but you will have to know this, that the atmospheric pressure is going to be then equal to the pressure of the gas that you're collecting plus the pressure of the water vapor, because that gas is always mixed with water vapor. All right, so this tells you about calculating the partial pressure of a dry gas collected over water. This is the part that you don't have to know. You do have to know this part, that the total atmospheric pressure once this gas is collected is equal to the gas plus the pressure of the water. Okay, this is purely a problem about partial pressure and Dalton's law, but it's pretty easy to understand. All right, so what I've shown here is what is the individual partial pressure of each gas in our atmosphere. All right, and what we know is, according to Dalton's law, that the total atmospheric pressure is the sum of all the individual gases in the atmosphere. So here is the percentage of gases in our atmosphere. Nitrogen is 78.0%, oxygen is 20.95%, argon 0.934%, and carbon dioxide is 0.035%. There's a little bit of other stuff. This is what we're going to do right now. Anyway, okay, and so what we know is that whatever atmospheric pressure is, it is the sum of the partial pressures of all these gases. So how do we calculate each one? Well, we know that standard atmospheric pressure at sea level is 760 millimeters of mercury, right? That's just standard pressure in millimeters of mercury. So if we're trying to find the partial pressure of each of these in millimeters of mercury, we are going to take that percentage and multiply it by 760. This should be just kind of obvious, right? What percentage of this total pressure is due to nitrogen? Well, nitrogen is 78.08%. So we're going to multiply, and we can't multiply by percents. We turn it into a decimal. We move the decimal place 2 places to the left, and we get this 0.7808 times 760 equals that. And this is what it is for oxygen. That's the partial pressure of oxygen, and this is the partial pressure of argon, and over there is the partial pressure of carbon dioxide. All right, hopefully that's fairly intuitive, and it's just about a matter of measuring the different percentages of the gases. All right, so this is a problem about Dalton's partial pressure. You should understand these, how to do these. What I'm not going to make you do is this one right here, okay? It requires looking something up in the appendix of the book and this and that, and it's not on the test, so I don't want to waste time with it.